In this video, we're going to go over complex numbers. We're going to talk about how to graph them, how to calculate the absolute value. We're going to work on problems on adding, subtracting, multiplying, dividing complex numbers, and even solving equations. But let's begin. So typically, you have something known as standard form, which is written as a plus bi. A represents the real portion of the standard or complex number. So a is a real number. B is the term bi is the imaginary part of the number. So let's say if we have the number 3 plus 4i. How can we graph this number, and also how can we calculate the absolute value of 3 plus 4i? So let's make a graph. The x-axis is the real axis. The y-axis is known as the imaginary axis. So the real part of the number is 3. So you want to travel 3 units to the right. The imaginary part is 4. So you want to go up 4 units. So the point 3 plus 4i lies right here. Now to calculate the absolute value of a plus bi, it's equal to the square root of a squared plus b squared. So basically, it represents the hypotenuse of this triangle. So what is 3 squared plus 4 squared? 3 squared is 9, 4 squared is 16. If you add them, you get 25, which is 5. So that's the hypotenuse of the right triangle that's formed. So the absolute value of 3 plus 4i is 5. Now let's try another example. Go ahead and plot this number, negative 5 plus 12i, and also go ahead and calculate the absolute value at the same time. So this time we need to travel negative 5 units to the left, that's on the real axis, and on the imaginary axis we need to travel 12 units up. So let's say it's somewhere in this vicinity. So that's the point that we need to plot. And let's make a right triangle out of it. So we went 5 units left, 12 units up. And let's calculate the hypotenuse formed by this right triangle. So the absolute value of a plus bi is equal to the square root of a squared, which is negative 5 squared, plus b squared, which is 12 squared. Negative 5 squared is positive 25, and 12 squared is 144. If you add these two numbers, you should get 169. And the square root of 169 is 13. So that's the hypotenuse of the triangle. So the absolute value of negative 5 plus 12i is 13. And this is where you plot it. Try this one. Go ahead and plot 8, negative 15i, and find the absolute value. So here's the real axis, the imaginary y-axis, and we need to travel 8 units to the right and down 15 units. So this time we're in quadrant 4. This is quadrant 1, 2, 3, and here's the 4th quadrant. So the point of interest is right here. That's how you plot it. but let's turn it into a triangle. So let's travel 8 units to the right and down 15 units. And let's find the hypotenuse of this triangle. So the absolute value of a plus bi is equal to the square root of 8 squared plus 15 squared. 8 times 8 is 64, and 15 times 15 is 225. Negative 15 times negative 15 is also positive 225. If we add 64 and 225, that's going to give us 289. And the square root of 289 is 17. So the absolute value is 17. That's the length of the hypotenuse. This is basically the 8, 15, 17 triangle. It helps to know your special triangles. So far we went over 3 of them. There is the 3, 4, 5 triangle. 3 squared plus 4 squared equals 5 squared. We talked about the 5, 12, 13 triangle. There's the 8, 15, 17 triangle. There's also the 7, 24, 25 triangle. These are the 4 most common right triangles that you'll encounter. You may also see any ratios of these special triangles. For example, 6, 8, 10 works as well because that's a ratio or a multiple of the 3, 4, 5 triangle. 10, 24, 26 also works. And there's some other ones like 9, 40, 41, and 11, 60, 61. Now, if you were asked to simplify these numbers, what would you do? Let's say if you have 2 numbers to simplify, the square root of 4 and the square root of negative 4. The square root of 4 will give you a real number, in this case 2, because 2 times 2 is 4. But what about the square root of negative 4? The square root of negative 4 is 2i. It's not just 2. The imaginary number I is equal to negative 1. So the square root of negative 4 is an imaginary number. Anytime you have a negative inside an even radical, or radical with an even index number, you're going to get an imaginary number. So go ahead and simplify these 2 numbers, the square root of 9 and the square root of negative 9. The square root of 9 is simply 3. The square root of negative 9 is the square root of 9 times the square root of negative 1. The square root of 9 is 3, and the square root of negative 1 is I. So you get 3i. Simplify these numbers. Square root 25, square root negative 25, negative square root 25, and negative square root negative 25. So the square root of 25 is simply positive 5. The square root of negative 25 is positive 5i. Negative square root 25 is going to be negative 5. And the last one is going to be negative 5i. Now, what about simplifying the square root of negative 18? The square root of 18 is not a perfect square. So what would you do in a situation like this? Well, it helps to know what the perfect squares are. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49. All of these numbers are perfect squares. You can take the square root of 9 and get a whole number 3. So you want to find out what perfect square goes into 18. The perfect square that goes into it is 9. 18 is 9 times 2. And let's not forget the negative sign. So we'll take out the negative 1. The square root of 9 is 3. We can't take the square root of 2 because it's not a perfect square. And the square root of negative 1 is I. So the final answer is 3 radical 2i. Let's try another example like that. Go ahead and simplify negative square root negative 50. So this is negative times square root 25 times square root 2 times square root negative 1. Now 25 is a perfect square. The square root of 25 is 5. And the square root of negative 1 is I. So this is the answer, negative 5 radical 2i. Try this one. What is the square root of negative 80? 16 is the highest perfect square that goes into 80. 16 times 5 is 80. And the square root of 16 is 4. So the answer is 4 root 5 times I. Here's one more example for you. Simplify negative square root negative 72. So what perfect square goes into 72? 9 goes into 72, that's a perfect square, but 36 goes into 72, and 36 is larger than 9. So we want to write this as 36 times 2. 72 divided by 36 is 2. That's how you could find this missing number. And let's not forget the square root of negative 1. The square root of 36 is 6, and the square root of negative 1 is I. So the final answer is negative 6 radical 2i. Now let's say if you were to get a question that looks like this. What is I raised to the 201? What is that? What does that even equal? How would you simplify that? Before we can do that problem, you need to understand a few things. So we know that I is equal to the square root of negative 1. Now what about I squared? And what about I to the third and I to the fourth power? You need to know what these values are equal to as well. I squared is equal to negative 1. If you square the square root of negative 1, the 2 and the radical will disappear, giving you negative 1. I to the third is basically I squared times I, because 2 plus 1 is 3. I squared is negative 1, so this is negative 1 times I, or basically negative I. So I to the third is equal to negative I, and I squared is negative 1. The last one is I to the fourth, which is I squared times I squared, and that's a negative 1 times negative 1, which is positive 1. Make sure you know these four values. Now let's say if you want to simplify I to the 6th power. What would you do? I to the 6th power is basically I to the 4th power times I squared. The reason why you want to break it up this way is because you know that I to the 4th is equal to 1 and I squared is negative 1. So therefore I to the 6th is simply negative 1. So let's try another example. Let's say if we want to simplify I raised to the 8th power. Now notice that 8 is a multiple of 4. So you can write it as I to the 4th times I to the 4th, or simply I to the 4th raised to the 2nd power, since you have 2 of them. And 4 times 2 is 8. Whenever you write it like this, you need to add the exponents. 4 plus 4 is 8. If you raise one exponent to another, you need to multiply. 4 times 2 is 8. Now we know I to the 4th is 1, and 1 squared is 1. So if you have an I number with an exponent that is a multiple of 8, it will always equal to 1. So for example, I to the 12th, this is 1 as well. It's I to the 4th raised to the 3rd power, since 4 times 3 is 12, and 1 to the 3rd power is still 1. Now what about, let's say, I to the 15th power? How can we simplify this number? So I to the 15 is I to the 12th times I to the third. So one of these numbers, you want it to be the highest multiple of 4 that's closest to 15. Multiples of 4 are 4, 8, 12, and 16. 16 is too much, so you want to choose 12, and 15 minus 12 gives you 3. So you want to break it up this way. And I to the 12th is I to the 4th raised to the third power, which is 1 to the third power. And we know that I cubed is equal to negative I. So the final answer is 1 times negative I, or simply negative I. Now, for those of you who may want to know another way or a systematic way of getting these two numbers, especially if this number becomes very large, here's what you could do. Take 15 and divide it by 4. If you type this in your calculator, you should get 3.75. Now, take the whole number portion of this decimal number and multiply it by 4. 3 times 4 is 12. That gives you this number. Now, the decimal portion of the number, multiply that by 4. So 0.75 times 4 gives you 3, which is the other remaining number. That's how you could find these two numbers if you ever have difficulty seeing what it is. Let's try another example. Simplify this one, I to the 29th. So this is I to the 28 times I. And I to the 28 is basically I to the 4th raised to the 7th, since 4 times 7 is 28. And this is going to be I to the 4th is 1, and 1 to the 7th power is 1. So 1 times I is simply I. So I to the 29th is the same as I. So one way to get these numbers, 28 and 1, take 29 divided by 4. 29 divided by 4 is 7.25. So then what you want to do is multiply 7 by 4, which gives you 28. That's the first number. And then the decimal portion of the number, 0.25, multiply that by 4, you should get 1, which is the other number. What about I raised to the 62? This is I to the 60 times I squared. And I to the 60 is basically I to the 4th raised to the 15th power. I to the 4th is 1. I squared is negative 1. 1 raised to anything is 1. So 1 times negative 1 is negative 1. Let's try one more problem. I raised to the 201. So let's work on this one. So what two numbers should we use? So let's use that process that we were dealing with earlier. 201 divided by 4. This is equal to 50.25. Now if you multiply 4 by 50, this will give you 200, and 4 times 0.25 is equal to 1. So this is going to be 201. Now 200 divided by 4 is 50. So you want to write it as I to the 4th raised to the 50th power times I to the 1st power. And I to the 4th is 1. And 1 raised to the 50th is simply 1. So it's 1 times I, which means the final answer is I. So for these type of problems, there's only 4 possible answers. It's either I, or I squared, which is negative 1, I cubed, which is negative I, or I to the 4th, which is 1. So it's always going to simplify to one of these 4 values. Our next topic is adding and subtracting complex numbers. So let's say if you have a problem that looks like this: 5 plus 2i plus 3 plus 7i. What would you do? So in a situation like this, all you need to do is combine like terms. The real numbers are 5 and 3, so we can add those two numbers. 5 plus 3 is 8. the imaginary numbers 2i and 7i, if we add them, that is going to give us 9i. And that's all you need to do for this particular problem. So let's try another example. Go ahead and add 7 plus 3i plus 6 plus 5i. So 7 plus 6 is 13. 3i plus 5i is 8i. Try this one. 4 plus 8i minus 3 minus 5i. Now, we only have a 1 in front of the first parentheses. So if we multiply everything by 1, it's going to stay as 4 plus 8i. Now here we need to distribute the negative sign. So it's going to be negative 3 plus 5i. So be careful when you have a negative, because some people may forget to change this sign. So now let's add the real numbers. 4 minus 3 is 1. 8i plus 5i is 13i. So this is the answer, 1 plus 13i. Now what is the absolute value of 1 plus 13i? So don't forget, the absolute value is going to be the square root of a squared plus b squared, or 1 squared plus 13 squared. 13 squared is 169, and if you add 1 to that, you're going to get the square root of 170. Now 170 is divisible by 10. This is the square root of 17 and the square root of 10. There's no perfect square that goes into 170. So this is the final answer. Go ahead and simplify this problem. 7 multiplied by 4 plus 3i minus 5 times 2 minus 6i. So first, let's distribute 7 to 4 plus 3i. So 7 times 4 is 28, and 7 times 3i is 21i. Now let's distribute the negative 5. Negative 5 times 2 is negative 10, and negative 5 times negative 6i is positive 30i. So now let's combine like terms. 28 minus 10 is 18, and 21i plus 30i is 51i. So this is the answer in standard form, or in a plus bi form. Try this. 4 plus the square root of a negative 25 plus 3 minus the square root of negative 81. Go ahead and simplify this expression. So this is 4 plus, we know the square root of 25 is 5, so the square root of negative 25 is 5i. And the square root of negative 81 is 9i. So we can add 4 plus 3, which will give us 7, and 5i minus 9i is negative 4i. So this is the answer. Try this one. 7 minus the square root of negative 9 minus negative 4 plus the square root of negative 36. So this is going to be 7 minus the square root of negative 9 is 9i, and then if we distribute the negative sign, this is going to be plus 4, and then minus the square root of negative 36, 6i. So 7 plus 4 is 11, and negative 9i minus 6i is negative 15i. So this is it. What about this one? What is 8i multiplied by 4i? What's the answer? How would you simplify it? 8 times 4 is 32. I times I is I squared. And as you recall, I squared is negative 1. So the final answer is negative 32. Try this one. What is 5i raised to the second power? So 5 squared is 25 times I squared. So this is going to be 25 times negative 1, which is negative 25. Now what about this? What's 3i times 5i times negative 7i? So 3 times negative 7 is negative 21. And I times I times I is basically I to the third power. 21 times 5 is 105. And I to the third is negative I. So the final answer is positive 105 times I. Simplify this expression. What is 5i multiplied by 4 minus 2i? Go ahead and work on this example. So let's distribute. 5i times 4 is 20i. And 5i times negative 2i. 5 times negative 2 is negative 10. I times I is I squared. So we could simplify the I squared part. I squared is negative 1. And negative 10 times negative 1 is positive 10. Now we need to put it in standard form, that is in a plus bi form. So we need to reverse the two numbers. Therefore the final answer is 10 plus 20i in standard form. Try this one. What is 5 minus 3i times 4 plus 7i? In this example, we need to FOIL. So what's 5 times 4? 5 times 4 is 20. And then 5 times 7i is 35i. Negative 3i times 4 is negative 12i. And negative 3i times 7i is negative 21i squared. So we can combine 35i and 12i. 35 minus 12 is 23. Negative 21i squared, that's negative 21 times negative 1, which is positive 21 plus 20, so that's 41. So the final answer in standard form is 41 plus 23i. Go ahead and work on this example. Multiply 6 minus 5i times 3 plus 8i. So go ahead and FOIL. 6 times 3 is 18, and 6 times 8i is 48i. Negative 5i times 3 is negative 15i. And finally, negative 5i times 8i is negative 40i squared. So let's combine 48i and 15i. So 48 minus 15, and that is equal to 33, or in this case 33i. And I squared is negative 1. So this is going to be 18. Negative 40 times negative 1 is plus 40. And 18 plus 40 is 58. So the final answer is 58 plus 33i. Now, what if you were to see a problem like this? 4 plus 5i squared. What would you do to simplify it in standard form? So what this means is that you have two 4 plus 5i terms multiplied to each other. So you want to write it out like this, expand it, and then FOIL. So 4 times 4 is equal to 16, and 4 times 5i is 20i. 5i times 4 is also 20i, and 5i times 5i is 25i squared. So let's combine the two middle terms. So that's going to be 20 plus 20 is 40, and 25i squared is negative 25. So what is 16 minus 25? 16 minus 25 is negative 9. So the final answer is negative 9 plus 40i. Here's one for you. Go ahead and simplify this expression in standard form. 5 minus 3i raised to the third power. So we need to expand it, or write it 3 times. So let's FOIL two of these binomials at one time. So let's start with those two. What's 5 times 5? 5 times 5 is 25. And then we have 5 times negative 3i, which is negative 15i. And then negative 3i times 5, which is also negative 15i. And finally, negative 3i times negative 3i, which is positive 9i squared. And we still have another one on the outside. So let's simplify this expression. Negative 15i and negative 15i adds up to negative 30i. We still have the 25, and 9i squared is negative 9. So now we can combine 25 minus 9, which is 16. So we have 16 minus 30i times 5 minus 3i. So at this point, we need to FOIL these two expressions. So 16 times 5 is 80. 16 times negative 3i is negative 48i. And negative 30i times 5 is negative 150i. And finally, negative 30i times negative 3i is positive 90i squared. So I believe my math is correct. Hopefully I didn't miss anything. So once again, let's add the two middle terms. What's negative 48 plus negative 150? These two, they're going to add to negative 198 times I. And 90i squared is basically negative 90. 80 plus negative 90 is negative 10. So the final answer is negative 10 minus 198 times I. Now, you need to know what's going to happen when you take a complex number and multiply it by its conjugate. So consider the complex number 3 plus 4i. The conjugate of this number is 3 minus 4i. It has the same a and b value. The only difference is this is a positive b value and this is a negative b value. When you multiply a number by its conjugate, you're going to get two terms initially, and ultimately it's going to simplify to a real number. The imaginary numbers will cancel. So here's the quick way to get the answer. It's going to be 3 times 3, which is 9, and 4i times negative 4i, which is negative 16i squared, and I squared is negative 1, so that's plus 16, which is 25. Now that's the fast way, but I'm going to show it to you by FOILing the entire problem. So 3 times 3 is 9. 3 times negative 4i is negative 12i. 4i times 3 is positive 12i. And finally, 4i times negative 4i is negative 16i squared. So notice that the middle terms cancel anytime you multiply a complex number by its conjugate. And I squared is negative 1, so negative 16i squared is negative 16 times negative 1, which is positive 16. And so the final answer is 25. So Notice that there's no more imaginary numbers. We just get a real number. So let's try this example. 5 minus 2i multiplied by its conjugate, 5 plus 2i. So for this particular example, we just need to multiply the first two terms, 5 times 5, which is 25, and the last two terms, negative 2i times 2i, which is negative 4i squared. So this is negative 4 times negative 1, which is plus 4. And 25 plus 4 is 29. Now let's say if you were to see a question like this. What is 3 times 7i squared compared to 3 plus 7i squared? So what's the difference between the two, and how would it affect the way you would solve it? So for the one on top, notice that the 3 is multiplied by the 7i. So therefore, this is equivalent to 3 squared times 7i squared. You can distribute the exponent. Below, you can't do that. You can't say this is 3 squared plus 7i squared. It doesn't work that way. For the one on the bottom, you need to FOIL it. You need to expand it first as 3 plus 7i times 3 plus 7i, and then FOIL. So if you have an addition or a subtraction sign between the 3 and the 7i, you have to FOIL it. If you have a multiplication or division sign, you can distribute the two. You don't have to FOIL it. Make sure you understand the difference. So for the example above, 3 squared is 9, 7 squared is 49, and I squared is just I squared. So 9 times 49 is 441 times I squared, which is negative 441. Now for the example below, we need to FOIL. 3 times 3 is 9. 3 times 7i is 63i, plus, I messed up there. 3 times 7 is not 63. 3 times 7 is 21. And we're going to get another 21i. And finally, 7i times 7i is 49i squared. So we have 9 plus 42i minus 49. 9 minus 49 is negative 40. Now what about dividing complex numbers? Let's say if we have 4 plus 3i divided by 5 minus 2i. What would you do to simplify this expression? If you're dividing complex numbers, focus on the denominator, which is 5 minus 2i. Multiply the top and the bottom of the fraction by the conjugate of the denominator. So if you see a minus sign, make sure this is plus. Whatever you do to the bottom, you must also do to the top, in order that the fraction maintain its value. So let's FOIL. 4 times 5 is 20. 4 times 2i is 8i. 3i times 5, that's 15i. 3i times 2i is plus 6i squared. Now, because these two are conjugates, we only need to multiply the first and the last term. The two middle terms will cancel. 5 times 5 is 25, and negative 2i times 2i is negative 4i squared. So let's combine 8i and 15i. 8 plus 15 is 23, and 6i squared is negative 6. Negative 4i squared is going to be plus 4. So 20 minus 6 is 14, and 25 plus 4 is 29. Now we need to put this in standard form, so let's separate this fraction into two smaller fractions. Let's divide both numbers by 29. So this is 14 over 29 plus 23 over 29 times I. So it's now in A plus BI form, or standard form. Try this one. Divide 8 by 6 plus I. So just like the last example, we're going to multiply the top and the bottom by the conjugate of the denominator. So let's distribute 8 to 6i. 8 times 6 is 48, and 8 times negative I is simply negative 8i. On the bottom we need to FOIL, but since they're conjugates, we could just multiply the first two. 6 times 6 is 36, and the last two, I times negative I, which is negative I squared. I squared is negative 1, so negative I squared must be positive 1. So this is equal to 48 minus 8i divided by 37. And now let's separate it into two smaller fractions. So the final answer is 48 divided by 37 minus 8 over 37 times I. So this is the answer in standard form. So for the sake of practice, try this one. 7 plus 2i divided by 3 minus I. Pause the video and work on this example. So let's multiply by the conjugate of the denominator. So on top, let's FOIL. 7 times 3 is 21. 7 times I, that's 7i. 2i times 3, 6i. And 2i times I, which is 2i squared. On the bottom, the first two, 3 times 3 is 9. And the last two, negative I times I, is negative I squared. So let's add 7i and 6i. That's going to be 13i. 2i squared is negative 2. Negative I squared is plus 1. 21 minus 2 is 19. 9 plus 1 is 10. So the final answer is 19 divided by 10 plus 13 divided by 10 times I. What if you have a complex number and you wish to divide it by an imaginary number? What would you do in this problem? So to simplify this expression, your goal is to get rid of the imaginary number. To do that, multiply the top and the bottom by I. If you can turn it into I squared or I to the fourth power, you can get rid of the imaginary number. So on top, let's distribute I. 5 times I is 5i, and negative 2i times I is negative 2i squared. On the bottom, I times I is simply I squared. So we have 5i, negative 2i squared is positive 2, I squared is negative 1. So this is 5i divided by negative 1, which is negative 5i, and 2 divided by negative 1 is negative 2. So this is equal to negative 2 minus 5i. So let's work on some more examples. Let's try 3 plus 2i divided by 7i. So for this example, we need to multiply the top and the bottom by I. So on top, if we distribute I, it's going to be 3i plus 2i squared. And on the bottom, we're going to have 7i squared. So 2i squared is negative 2. 7i squared is negative 7. So I'm going to rewrite it as negative 2 plus 3i. So it's going to be in standard form. So negative 2 divided by 7, or negative 7, that's positive 2 over 7. And then 3i divided by negative 7 is negative 3 over 7 times I. So this is the answer in standard form. Go ahead and simplify the expression. So this one, it looks weird, but it's not that bad. We just got to multiply the top and the bottom by I. So on top, it's going to be 9i. On the bottom, I to the fourth. And remember, I to the fourth is 1. So the final answer is simply 9i. Now, what if you were to see a problem that looks like this? 5 minus 2i divided by 2 plus 3i squared. What would you do to simplify it? So before we can multiply by the conjugate or by I, we need to simplify this expression. We need to put it in a plus bi form. So let's FOIL 2 plus 3i times another 2 plus 3i. So 2 times 2 is 4. 2 times 3i is 6i. And 3i times 2 is also 6i. And then 3i times 3i is 9i squared. On the top, everything's going to be the same. 6i plus 6i is 12i, and 9i squared is negative 9. So now we can combine 4 and negative 9, which is negative 5. So it's negative 5 plus 12i on the bottom. So now at this point, we can multiply the top and the bottom by the conjugate of the denominator. That is negative 5 minus 12i. So on top, let's distribute. 5 times negative 5 is negative 25. 5 times negative 12i, that's negative 60i. And negative 2i times negative 5 is positive 10i. And finally, negative 2i times negative 12i is positive 24i squared. So hopefully I didn't miss any negative signs or anything like that. It's very easy to make a mistake. Things happen. But I'm just double checking my work. So everything looks good so far. On the bottom, since they're conjugates of each other, we could just multiply the first two and the last two. Negative 5 times negative 5 is positive 25. 12i times negative 12i is negative 144i squared. So now let's combine negative 60 and 10i. Negative 60 plus 10 is negative 50. 24i squared is negative 24. And negative 144i squared is plus 144. So now let's add negative 25 and negative 24, which is negative 49. 25 plus 144 is 169. So the final answer for this problem is negative 49 divided by 169 minus 50 over 169 times I. So as you can see, whatever expression you have that's a complex number, you can always put it in standard form. There's always some technique that you can employ to put it in a plus bi form. So let's say if you have two equations, x squared minus 36 is equal to 0, and also x squared plus 36 is equal to 0. What would you do to solve for x? In the first example, we can factor it using the difference of squares method. The square root of x squared is x. The square root of 36 is 6. One will be positive and the other will be negative. So therefore, x is equal to -6 and +6. So that's what you could do if you have the difference of perfect squares. If you have the sum of perfect squares, it's going to be x plus 6i times x minus 6i. So therefore, x is equal to plus or minus 6i. Notice that these two are conjugates of each other. So you could check your answer by FOILing. So x times x is x squared, and 6i times -6i is -36i squared, which is +36. So whenever you're factoring the sum of perfect squares, you're going to get imaginary numbers. If it's a difference of perfect squares, you're going to get real numbers. So let's try some more examples solved for x. So let's try this one. 3x squared plus 48 is equal to 0. Let's put it in factored form and then we'll solve for x. So we can take out the GCF, which is 3. 3x squared divided by 3 is x squared. 48 divided by 3 is 16. So notice that we have the sum of perfect squares. X squared is a perfect square. 16 is a perfect square because you can take the square root of it. The square root of x squared is x. The square root of 16 is 4. But we're going to have 4i and 4i. One is going to be positive, the other will be negative. So therefore, x is equal to positive 4i and negative 4i. So let's try another one. 4x squared plus 100 is equal to 0. Go ahead and work on that example. So let's take out the greatest common factor. 4x squared divided by 4 is x squared. 100 divided by 4 is 25. So to factor it, it's going to be x plus 5i, since the square root of 25 is 5, and x minus 5i. So to solve for x, let's set each factor equal to 0. So in this example, we need to subtract both sides by 5i. Here we need to add by 5i. So we can see that x is equal to negative 5i and positive 5i. Consider this one. Negative 9x squared minus 100 is equal to 0. What would you do to solve this particular example? What I would recommend is taking out the GCF, which is negative 1. Negative 9x squared divided by negative 1 is 9x squared. Negative 100 divided by negative 1 is plus 100. So notice that we have the sum of perfect squares. 9 and 100 are perfect squares. The square root of 9x squared is 3x. The square root of 100 is 10. But it's going to be 10i, since we know we have the sum of perfect squares. So one is going to be positive and the other is going to be negative. So we could write two equations. Let's set each factor equal to 0. So 3x plus 10i is equal to 0, and 3x minus 10i is equal to 0. So therefore, x is going to be negative 10i divided by 3, and it's also going to be positive 10 over 3 times I. Let's try this one. X squared plus 1 over 9 is equal to 0. So here we have a fraction. Go ahead and solve for x. The square root of x squared is x. The square root of 1 over 9 is 1 divided by 3. Now let's not forget to put the imaginary numbers. So we're going to have a positive and a negative sign. So we could see that x is equal to negative 1 over 3 times I and positive 1 over 3 times I. And that's all you got to do for that particular example. So how would you solve this particular equation? 3x squared plus 4x plus 7. Now typically you would try to see if you can factor this expression. Since we have a trinomial, 3 times 7 is 21. If we could find two numbers that multiply to 21 but that add to the middle term 4, then this expression is factorable. The only factors of 21 are 1 and 21 and 3 and 7, which none of these add up to 4. We also have negative 1 and negative 21 and negative 3 and negative 7. Now that doesn't add to 21. Unless we had like negative 3 and positive 7, that would add to 4. But negative 3 times 7 doesn't multiply to positive 21. It multiplies to negative 21. So this expression is not factorable. So therefore, the only way to solve it is either to complete the square or to use the quadratic formula. This equation is in standard form ax squared plus bx plus c. So a is 3, b is 4, c is 7. So let's use the quadratic formula. X is equal to negative b plus or minus square root b squared minus 4ac divided by 2a. So b is 4, which means that b squared, 4 squared is 16, a is 3, c is 7, divided by 2 times a, or 2 times 3. So this is going to be negative 4 plus or minus 16. Now 3 times 7 is 21, and 21 times 4 is 84, divided by 6. So now what is 16 minus 84? 16 minus 84 is negative 68. Can we simplify the square root of 68? It turns out that we can. The square root of 68 is basically 4, the square root of 4 times the square root of 17. 4 times 17 is 68. Now let's not forget the negative 1. The square root of 4 is 2, and the square root of negative 1 is I. So this is what we have at this point. So there's two answers, but let's separate it into two fractions. So it's negative 4 divided by 6 plus or minus 2 radical 17 divided by 6 times I. So we can reduce 4 over 6. If we divide both numbers by 2, it's going to be negative 2 over 3. And 2 over 6, we can reduce it. 6 divided by 2 is 3, but it's going to be on the bottom. So it's the square root of 17 divided by 3 times I. So the two answers are negative 2 over 3 plus root 17 over 3 times I. That's in a plus bi form. And the other answer is negative 2 over 3 minus root 17 over 3 times I. Let's try another example. Try this one. 2x squared minus 3x plus 9. Go ahead and solve for x. So let's use the quadratic equation one more time. It's negative b plus or minus square root b squared minus 4ac divided by 2a. So in this problem, b is negative 3. So b squared, or negative 3 squared, that's going to be 9. A is 2, and c is 9, divided by 2a, or 2 times 2. So negative times negative 3 is positive 3. 4 times 2 is 8. 8 times 9 is 72. And 2 times 2 is 4. So what is 9 minus 72. 9 minus 72 is negative 63. So notice that we could simplify root 63. Root 63, 63 is basically 9 times 7. And let's not forget the square root of negative 1. So the square root of 9 is 3, and the square root of negative 1 is I. So this is what we now have. So let's separate it into two fractions. So this is going to be 3 over 4 plus or minus 3 radical 7 divided by 4 times I. And so the two answers are 3 over 4 plus 3 root 7 over 4 times I. And the second answer is 3 over 4 minus 3 root 7 divided by 4 times I. So these are the two imaginary solutions. Now what if you were to see an equation that looks like this? 2x times x minus 3 is equal to 5. Or rather, let's say negative 5. What would you do to solve for x? So notice that this is a quadratic equation, but not in standard form. So we got to put it in standard form before we can use the quadratic formula. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. And let's add 5 to both sides. So it's 2x squared minus 6x plus 5, which is equal to 0. So now we can use the quadratic formula, now that it's in standard form. So now b is negative 6, and then we have b squared, or negative 6 squared, minus 4, and a is 2, c is 5, divided by 2a, or 2 times 2. So this is going to be 6 plus or minus square root. Negative 6 squared is 36. 2 times 5 is 10. And 10 times negative 4 is negative 40. And 2 times 2 is 4. So let's make some space. So 36 minus 40 is negative 4. And the square root of negative 4, the square root of 4 is 2, so the square root of negative 4 is 2i. So let's separate it into two fractions. So this is going to be 6 over 4 plus or minus 2 over 4 times I. 6 over 4 reduces to 3 over 2 if you divide the top and bottom by 2. And 2 over 4 reduces to 1 over 2 times I. So therefore, we have two answers, 3 over 2 plus 1/2 I. And the second answer, 3 over 2 minus 1/2 I. And that's it for this problem. Now what if you were to see an equation like this? 6x plus 2i is equal to 18 plus 12yi. So there's two variables, x and y. What can you do to solve for x and y? Now you need to keep in mind that these complex numbers have two components, the real component and the imaginary component. The real component on the left side is 6x because it doesn't have an I attached to it. The real component on the right side is 18. So therefore we could say that 6x must be equal to 18. Now the imaginary component contains an I. The imaginary component on the left side is 2i and on the right side is 12yi. So therefore we could say that 2i is equal to 12yi. On the left we could divide by 6, so we could say x is equal to 3, and on the right side to solve for y we could divide both sides by 12i to get y by itself. So On the right, 12i will cancel, leaving us with y. On the left, the I variable will cancel, and it's 2 over 12. If you divide it backwards, 12 divided by 2 is 6. So 2 over 12 must be 1 over 6. So this is the answer. X is equal to 3, and y is equal to 1 over 6. Try this one. 3x plus 4i is equal to 15 plus 16yi. So let's set 3x equal to 15. Since both of those terms are real numbers. And let's set the imaginary parts equal to each other. So 4i is equal to 16yi. So let's divide by 3. 15 divided by 3 is 5, so x is 5. And for the second equation, let's divide by 16i. So on the right side, all we have is just y. On the left side, the I variables cancel. 16 divided by 4 is 4, so 4 over 16 must be 1 over 4. And so, those are the answers. Try this one. What is x plus 4i multiplied by x minus 4i? And let's say that's equal to 41. What is the value of x? So we have two conjugates multiplied to each other. So we can multiply the first and last terms. X times x is x squared, and 4i times negative 4i is negative 16i squared. And since I squared is negative 1, negative 16i squared is plus 16. So now what we need to do is subtract both sides by 16. 41 minus 16 is 25. So we could take the square root of 25. Therefore, x is going to be plus or minus 5. So that's the answer to the problem. Now let's say if you're given the imaginary solutions to an equation and you're asked to write that equation, what would you do? So first you want to write it in factored form. If your answer is 3i, you want to write x minus 3i. If it's negative 3i, write x plus 3i. Of course, this is probably equal to 0. You may or may not need that 0. And then you want to FOIL. Since these are conjugates of each other, we could just multiply the first and the last two terms. So it's going to be x squared times negative 9i squared, which is x squared plus 9. So that's how you can find the equation if you're given the solutions. So let's try another example. So let's say if you're given just one solution, 4i. What's the equation? Now, for a quadratic equation, imaginary numbers, they come in pairs. So if you have 4i, you must also have the conjugate negative 4i. So therefore, we can write x minus 4i times x plus 4i. And we know it's going to be x squared minus 16i squared, which is x squared plus 16. So basically, you're working backwards. Now, let's say if you're given one of two imaginary solutions, let's say 4 plus 3i, and you want to write the equation. First, you need to find the other imaginary solution, which is going to be the conjugate, 4 minus 3i. So how can we write these two numbers in factored form? So here's what you need to do. Notice that you have a plus 4. Change the sign of 4, and it's going to be minus 4. And then change the sign of plus 3i, it's going to be minus 3i. Do the same thing for the other side. So we have a positive 4, change it to negative 4. Negative 3i, change it to positive 3i. And so now we need to FOIL. So there's an easy way and there's a long way. We're going to do it the long way first, and then we'll do it the easy way. So you'll see why it works. Here we have three terms. Initially, when we FOIL it, we should get 9 terms. And then we'll simplify it. So x times x is x squared. X times negative 4, negative 4x. X times 3i, that's going to be 3xi, and then negative 4 times x, negative 4x, negative 4 times negative 4 is 16, and negative 4 times 3i is negative 12i. And then we have negative 3i times x, which is negative 3xi, and then negative 3i times negative 4, that's positive 12i, and finally negative 3i times 3i is negative 9i squared. So now what terms cancel? We can cancel the 3xi and the negative 3xi. We can also cancel the negative 12i and a 12i. So what do we have left over? So we have x squared, and these two combine to form negative 8x plus 16 minus 9i squared. Negative 9i squared is positive 9, and 16 plus 9 is 25. So this is the quadratic equation, x squared minus 8x plus 25. Now let's start back from our original factored expression, which was x minus 4 plus 3i and x plus 4, minus 4, but minus 3i. So our goal is to get this answer, x squared minus 8x plus 25. So another way in which you can do it is you're going to multiply x minus 4 times x minus 4, which is x minus 4 squared. And then you're going to multiply these two. 3i times negative 3i. So when you FOIL x minus 4 squared, because it's a perfect square, it's going to be x squared, and it's going to be negative 4x plus negative 4x. And negative 4 squared is going to be 16, negative 4 times negative 4. And 3i times negative 3i is negative 9i squared. So this is going to be x squared minus 8x plus 16 plus 9, which turns into this. So that's how you can do it the fast way. Let's try another example. So given these two solutions, go ahead and write the quadratic equation. So let's write it in factored form. Since we have positive 5, it's going to be x minus 5 plus 2i and x minus 5 minus 2i. So this is the same as x minus 5 squared plus 2i times negative 2i. So x minus 5 squared, that's going to be x minus 5 times x minus 5, which is x squared, minus 5x, minus 5x, and negative 5 times negative 5 is 25. And 2i times negative 2i is negative 4i squared. So this is going to be negative 10x plus 25. Negative 4i squared is plus 4. So the final answer is x squared minus 10x plus 29. So this is it. Now, what if you were to see something like this? X is equal to the square root of 7 plus 3i. What's the other answer? The other answer is going to be root 7 but minus 3i. So let's go ahead and convert this into a quadratic equation using both techniques. So this is going to be, since we have a positive in front of the radical 7, it's going to be x minus root 7 minus 3i and x minus root 7 but plus 3i. So let's FOIL it the long way. X times x is x squared. X times negative root 7, that's negative root 7x, and plus 3xi. And then negative root 7 times x, and then this is going to be negative root 7 times negative root 7, which is simply -7 because that's actually +7. The two negative signs cancel. Root 7 times root 7 is the square root of 49, which is 7. And negative root 7 times 3i, that's going to be -3 root 7i. Negative 3i times x is -3xi. Negative 3i times negative root 7, -3, well, it's going to be positive now, +3 root 7 times I. You got to be careful. It's very easy to like make a mistake. Negative 3i times 3i is -9i squared. So now let's cancel the terms that can be canceled. That's 3xi and also 3 root 7i. So we're left with x squared. These two we could combine. That's going to be 1 radical 7 plus 1 radical 7 is 2 radical 7. So this is going to be -2 radical 7 times x. And then plus 7. -9i squared is going to be plus 9. So the final answer is x squared minus 2 root 7 times x plus 16. Now let's get the same answer using the other technique. So in factored form, it was x minus root 7 minus 3i times x minus root 7 plus 3i. So this is equivalent to being x minus root 7 squared and then plus 3i times -3i. So x minus root 7 times x minus root 7, that's going to be x squared minus root 7x minus another root 7x. And negative root 7 times negative root 7 is positive 7. And 3i times -3i is -9i squared. So we can see that these two, they're going to add to -2 root 7x. And then this is going to be 7. -9i squared is plus 9, which these two will become 16. So you get the same answer. Now let's say if you're given a quadratic equation in standard form, ax squared plus bx plus c. And you want to find the sum and the product of the roots. In a quadratic equation, there's usually two roots, two real solutions or two imaginary solutions. Or one real solution that's the same, but two answers. How can we find the sum and the product of the roots if we're given the quadratic equation? The equation is this. The sum is equal to -b divided by a. And the product is c divided by a. So let's try an example. Let's say if we have the quadratic equation x squared plus 36 equals 0. What is the sum and the product of the roots in this equation? So this is 1x squared plus 0x plus 36, which is equivalent to x squared plus 36. So we can see that b is 0. So the sum is going to be -0 divided by a, which a is 1. So the sum is 0. The product is going to be c over a. C is 36. So it's 36 over 1, which is 36. Now let's prove it. So the equation x squared plus 36 can be factored as x plus 6i times x minus 6i. Therefore, the roots are -6i and positive 6i. So if we are looking for the sum of the roots, the sum of the roots is just adding the two answers. -6i plus 6i adds up to 0. Now the product, we just got to multiply it. -6i times 6i will give us the product, which is -36i squared. And since I squared is -1, this is going to be positive 36. Let's try another example. X squared minus 4x plus 29. So given this quadratic equation with three terms, in other words a trinomial, find the sum and the product of the roots. So the sum of the roots is negative b divided by a. The product is simply c divided by a. So use the equation and also find the solutions and confirm the answer. So let's use the equation first. B is negative 4. A is 1. So the sum is 4, which I'm going to write it right here. The product is C over A, where C is 29, A is 1. So the product is 29. So now let's find the solutions and let's confirm that answer. So let's solve for x using the quadratic equation. Negative b plus or minus square root b squared minus 4ac divided by 2a. So b is negative 4. And b squared, negative 4 squared. Negative 4 times negative 4 is 16. A is 1. C is 29. Divided by 2a, or 2 times 1. Negative times negative 4 is positive 4. 4 times 29, that's going to be 116 divided by 2. (16 minus 116 is negative 100. Now the square root of 100, we know it's 10, so the square root of negative 100 must be 10 times I, which is a nice number. So now let's separate it into two fractions. That's going to be 4 over 2 plus or minus 10 over 2. And 4 divided by 2 is 2. 10 over 2 is 5. So there's two answers. 2 plus 5i and 2 minus 5i. So these are the two complex solutions. Now that we have the solutions, we can confirm if the sum is 4 and if the product is 29. So let's go ahead and do that. To find a sum, we need to add the two solutions. 2 plus 5i plus 2 minus 5i. So 2 plus 2 is 4. 5i plus negative 5i, they cancel. It's 0. So the sum is indeed 4. Now let's find the product of the two solutions. So the product is going to be 2 plus 5i multiplied by 2 minus 5i. Now because these are conjugates of each other, we can multiply the first two and the last two. 2 times 2 is 4. 5i times negative 5i is negative 25i squared. Negative 25i squared is plus 25, since I squared is negative 1, and 4 plus 25 is 29.